I'm Martin Osborne. I'm going to tell you about text2bib. If you have a file of references in bibtex format like this one, and you want to put them in a document nicely formatted, we all know what to do. But what if you want to go in the other direction? Suppose you have this, or this, or this, and you want to generate this bibtex item. Then things aren't so simple. Before going further, let me ask an obvious question. Why would you want to do such a thing? Well, maybe you're a tech user who's been hard coding references in your documents and now you want to switch to using bibtex. Or maybe you're switching to TeX from some other text formatting system. Or maybe you're not using TeX at all, but want to import items into a reference manager like Zotero using bibtex as an intermediate format. Or maybe you run a journal that typesets papers using TeX and uses bibtex for the references, but you have to deal with authors whose papers contain lists of hard-coded references. That was my situation in 2007 when I initiated the development of text2bib. If you want some hard evidence of a demand for converting text references to bibtex, this question on Stack Exchange has been viewed on average about 18 times every day over the last decade. Okay, so how should you go about converting text references into bibtex format? In this era, the answer seems blindingly obvious. Use AI. But let's just check that with Google. Hey Google, how can I convert text references into bibtex format? To convert text references to bibtex format, you can use online tools like text2bib. Okay, so let me tell you about my hard-coded algorithm and then come back to AI. In the spring of 2007, I was working with a group of economists on a new independent open access journal, Theoretical Economics. And we needed to have a low-cost way of formatting the references in published papers consistently. I decided to use bibtex, which meant that we needed to convert the hard-coded reference lists that most authors had in their papers into bibtex files. I hired an undergraduate at the University of Toronto with funding from the university to start work on an algorithm. He wrote it in PHP. I don't know whether the choice of that language was his idea or mine. Probably it's not the most natural language to use for this purpose, but that's the way it is. When the student graduated in the summer of 2007, I took over the project and I have developed it since then. At some point, I wrote a front end for public use using a rather niche framework. In the summer of 2023, I started recoding the system using the widely used Laravel framework. I launched the new version in March 2024. The source code is available on GitHub. Before showing you how it works, let me talk about a couple of issues. First, there isn't one bibtex entry for any given reference. There are many possible entries depending on how the bibtex entry is going to be used. Here's a reference to a book. If it's going to be used with biblatex, then here's the right version of the bibtex entry. But the highlighted fields aren't supported by most bibtex style files, so if the bibtex database is going to be used with bibtex rather than biblatex, then the right version is probably this one, with the subtitle included in the title and the translators and ISBN in the note fields. But some bibtex style files do support the extra fields. So what I've done is create a database of bibtex style files, recording the features of each file. Here's the page on text2bib.org that lists the files. So far, I've cataloged 84. If you click on a file name, here I'm clicking on ACM reference format, you see the fields it supports. Green means the field is supported, red means it's not supported, and a sample reference list. This particular style is a rarity in supporting many fields, though curiously it does not support URL date. When a user uploads to text2bib a file for conversion, they are asked how they intend to use the bibtec file that will be created. And if they select bibtec, they are asked to select the style they plan to use. The output of the script is then tailored to their choices with the correct fields populated. You might be interested in the popularity of the various styles. Here's the distribution of the number of users selecting each bibtec style file. As you can see, the APA style is the most popular, a style that does not support any fields containing digital information like the DOI, ISBN, or URL. The first style on the list to support a significant number of such fields is ACM reference format. Of course, some users of text2bib aren't using either biblatex or bibtec. Instead, they're using the bibtec database as an intermediate format to enter references into a reference database manager. In fact, that's what the majority of people using text2bib are up to. These data also show, as you can see, that about twice as many text2bib users use bibtec than use biblatex. Here's the second issue I want to talk about before explaining how my algorithm works. Take a look at this bibtec entry. Obviously, it cannot be recovered from this reference because some information is missing in the reference, like the author's first names and the DOI. Unless, that is, we match the reference with some external data. My original purpose in creating text2bib was simply to have a way to consistently format authors' references, whatever they supplied, and the system didn't use any external data. But at the suggestion of Paulo Ney de Souza, who's made many helpful suggestions, in November 2024, I added the option to match references with data from Crossref. I'll talk about that feature a bit later. So how does the algorithm work? Here's a reference. The main features of a reference that the algorithm uses are the capitalization of the letters, uppercase versus lowercase, the punctuation, for example, commas, periods, and quotation marks, whether the characters are letters or numbers, and some keywords like and, in, eds, and many more. The list is long. These are available in multiple languages. The algorithm uses also the presence of words in an English dictionary when deciding, for example, whether a word is the name of an editor or the first word of a book title. It also uses some auxiliary data, like lists of von names and abbreviations used in journal names, and lots of pattern matching using regular expressions, hundreds of them. My general approach is to make the system good enough without attempting to make it comprehensive, because that would seem to require 1,000 times as much code. For example, here's the list of words that the system knows mean and in a list of authors. The defining characteristic of these words is that they're the ones I've noticed in submitted files. So how does the conversion proceed? First, it removes any DOI, URL, ISBN, or similar component based on pattern matching using regular expressions. Then it determines where the author string ends and breaks it into authors. To do so, it first checks whether the string matches one of a bunch of patterns. Currently, there are 43 of them. If no pattern matches, it works through the string character by character, forming names based on punctuation and capitalization. It terminates the author list when it comes to a string that looks like the year or the start of the title. It might look like the start of the title because it begins with quotation marks or is a string of several words without any punctuation, for example. This part of the algorithm isn't perfect, but its accuracy is pretty high. If the year is next, it extracts it. It assumes the title comes next. It determines where the title ends based on punctuation, capitalization, and whether the following string matches the pattern of publication information for some item type. It takes the remainder of the string to be the publication information. Based on its characteristics, including the presence of various keywords, the system assigns a type to the item. For this example, that's easy because the remainder fits a standard pattern for a journal article. The system can detect the main item types listed here. They're listed in the order of the percentage of items in the files uploaded to text2bib. Here are the percentages. A large majority of items are articles. The next step is to parse the publication information into its components, which again, for this example, is easy. For an in-collection or in-proceedings item, that extraction process is pretty complicated. The book title and editors, as well as the address and publisher, have to be extracted. The code for this component of the algorithm alone is about 2,000 lines long. Once all the items in a file have been converted, the last step is to assign a label to each item in a style of the user's choosing. So this item, as far as the algorithm is concerned, looks pretty much like this. It's an easy case because the presence of the year clearly marks the end of the author string, the title is delimited by quotation marks, and the publication information conforms to a common pattern for journal articles. Here's an example that's much more challenging. Is that the last author and the start of the title, or the title and the subtitle? Is that the first editor or the last words of the book title subtitle? Is that the address and publisher or the other way around? This example is even more challenging. You might think that it would be a good idea to compile lists of journal names, publishers, and publication cities and use them to match components of references. I initially did that, but I've abandoned it completely for journal names and mostly for publishers and cities. Some journal names are words or phrases that can occur in titles. Here are a few such journal names starting with the letter A. Names like these have to be given special handling, which is costly in terms of code. And most publication cities are like that. They can appear in titles and also in the names of publishers. Also, some journal names are substrings of other journal names, like these ones, and thus also require special handling. I've found that letting the algorithm decide what's a journal name, what's a publisher, and what's a publication city is much simpler and more reliable than matching from lists of existing names. My approach to handling languages other than English is ad hoc. A user has the option to tell the system that the auxiliary words in their references, like the phrases for retrieved from or an online reference, are in one of a small number of languages other than English, but whatever they choose, the algorithm recognizes most keywords, like and editor and translated by, in several languages, so that a file of references in which the auxiliary words aren't all in the same language, with some references using English and some using another language, for example, is processed correctly. The fact that the algorithm in a few instances uses the fact that a word is in an English dictionary as evidence in favor of its not being a name means that the conversion of references with non-English text, in titles for example, may be less accurate than the conversion of references in English. However, the dictionary lookup is used only in a minor way, and I don't think there's much of a degradation in the quality of the conversion for this reason for languages other than English. Now, it turns out that languages other than English are chosen infrequently by users. Here's the distribution. So about 98% of users choose English. The languages in non-Latin alphabets that use uppercase and lowercase letters in the same way that they use in English, like Russian, the algorithm seems to work fairly well. Here's an example. That's the source, and here's the output of the algorithm, which I believe is correct. But of course, the system cannot handle languages like Chinese and Arabic that use other rating systems. Let me give you a quick demonstration of the system. You have a file of references like this one, in which the items are separated by blank lines, or like this one, in which each item is on a single line. You select the file and choose the appropriate options. Most importantly, what you plan to do with the file, what separates the items in the file, and the language of the auxiliary words. And then submit the file for processing. You get back the references in BibTeX format, which you have the opportunity to edit. If you correct an item, you have the opportunity to submit an error report. There are also links that you can use to check the item in Google Scholar and JSTOR. At any point, you can download the BibTeX file that's been created. Whenever I modify the algorithm to accommodate an item that's not converted correctly, I add the item to a table of examples. And I make sure that all of the existing examples are still converted correctly. Currently, there are over 1,200 such examples. Earlier, I mentioned that one option when you submit a file for conversion is to ask the system to attempt to find each item in crossref.org and then give you the option to make corrections based on the crossref data. In principle, this functionality could be useful, but it suffers from several problems. First, querying crossref is very slow. Processing 20 items takes about a minute, whereas if crossref is not used, a file of that size takes about 1/3 of a second. The second problem is that the quality of the crossref data is low. As I understand it, crossref reports whatever data publishers supply, which means there's no consistency. Here's an example. For this reference, here is the output that crossref produces. There are several problems with it. First, the author's last names are in all caps. Secondly, and more strangely, the uppercase I in every last name is rendered with a dot, as in Turkish and related languages, although at least some of these names, for example the first one, are definitely not Turkish. Third, the journal name is in all caps and is followed by its abbreviation in parentheses, which shouldn't be there. Fourth, the month is rendered as text rather than a numeral as required by BibLaTeX, and actually doesn't appear in the published paper, though it may still, of course, be correct. Last, the DOI is not extracted from the URL, but rather the URL appears in the URL field. I didn't have to look far to find this example, and it's easy to find errors in other examples in users' files, but I don't know what the overall accuracy rate is in crossref. However, if I wanted to check the accuracy of some references, I would locate them in Google Scholar and check the published papers themselves. A third problem with crossref, for the purposes of text2bib, is that their matching algorithm is poor. The best match can be the wrong item, even if the reference is exactly correct. Lastly, and this is not a problem due to crossref itself, many users who choose the option, and there aren't many who do so, simply ignore the corrections that crossref makes to their references, even when the crossref data is correct. I have no idea why they do that. So overall, my assessment is that the addition to text2bib of the possibility of matching references in crossref does not have great value. I don't have a good estimate of the accuracy rate of the conversion algorithm. For source files that are free of errors, the rate seems fairly high. But many source files contain errors, and even small ones like missing spaces between words, or mistakes in punctuation, or superfluous text at the end of the reference, can cause the algorithm to produce completely incorrect results. The reason, of course, is that the algorithm doesn't understand language, but rather implements a set of rigid rules. For the same reason, the algorithm has difficulty with items like this made-up example, in which determining the boundaries between the list of authors and the title and between the title and the journal name require an understanding of language. Are artificial intelligence and text processing the second and third authors, or do they begin the title? Is computation the last word of the title or the first word of the journal name? What is the future of the system? Since I re-implemented it 15 months ago, I've made many major improvements. Currently, I don't have any ideas for further significant development. Of course, the most satisfying changes are ones that involve just a few added lines of code, or sometimes even a reduction in the number of lines of code, and at the same time improve lots of conversions. Writing many lines of code to deal with a minor edge case is much less satisfying. The code is open source on GitHub, so if you have some ideas for improvements, please code them and submit some pull requests. I believe that the next big improvement will come with the use of AI. Large language models like ChatGPT and Gemini currently do an excellent job of converting references, certainly much better in my albeit limited tests than text2bib. Here's an example. Not only can they convert references perfectly, but also they can supply missing information like authors' first names and DOIs. And they can also correct errors. Presumably the training data included all of Google Scholar. The only advantages of text2bib that I can see are that it is currently much faster than the LLMs, although I'm sure the LLMs will soon catch up, and that it's free, although the LLMs are also free up to a point and aren't expensive for an individual who exceeds the free usage limit. Of course, it's vast overkill to use an LLM for this purpose. It would be better to train a much smaller model to do the conversion. And in fact, people have done so. Among the 1.8 million plus models available on huggingface.co, 4 match the filter BibTech, and one of these has an implementation that you can try out. In my tests, it hasn't done a very good job. For example, it never formats multiple authors correctly, and it's very slow. But it's much smaller than ChatGPT, and perhaps it's possible to train it to do a better job using data from text2bib, or maybe the model on which it was trained could be trained using text2bib data. Or maybe using a large model like ChatGPT, which in my tests has produced perfect results, is the way to go. text2bib has converted over 1 million references since I relaunched it in March 2024, and it continues to be used to convert around 2,000 items each day. I ask every new user who registers how they found the site, and on average 2 per day say that ChatGPT or another AI system referred them to it. But I'm sure that the future lies with an AI system itself doing the conversions.